Hey everyone, Steve Perry here. This video accompanies Unit 4 of the Node.js course available from IBM Code. In this video, I'm going to talk about a few basic Node.js concepts: the node module system, Node's non-blocking I/O model with examples, and how to load test your code using Node's HTTP API and a load test tool. All of the examples you'll see in the video are showcased in Unit 4 of the course, and the code is available in GitHub. Links to the GitHub repo and everything else you see in the video are in the video description. Let's get started. As a Node developer, there are three types of modules you'll use. Built-in modules like this one from the HTTP API, modules you download from the NPM registry like load test, and custom modules you write yourself. That's what we're going to do now, write a module. What is a module? From the doc, it looks like a module is a file with JavaScript code in it. And from the example, in order to reference one module from another, you use require. Got it. Open up your editor. I'm using VS Code for the video. Create a new file and call it foo.js. Now create a simple function called hello that just prints hello from and the fully qualified JavaScript file name using console.log. Save foo.js. Next, create another new file called bar.js. In it, get a reference to the foo module using require like the doc says. Call the hello function and save bar.js. Now run it, and we get an error. Foo.hello is not a function. But it is a function. Maybe I'm missing something. Let's consult the documentation again. So it looks like in order to make a function visible outside of the module in which it's defined, we have to export it like this. Module.exports.hello equals hello. Save the file, run it again, and there's the message. Congratulations, you've written your first Node module. I'm proud of you, champ. Proud of you. To really understand Node, you need to understand the difference between blocking and non-blocking calls. Blocking occurs when JavaScript code running on the Node runtime has to wait until some non-JavaScript operation completes. The docs have a couple of small examples showing the difference. In the first example, the file is read synchronously, so every line of code you see executes one after the other. In the second example, the file is read asynchronously, so while the file is being read, anything after the asynchronous callback ends will be executed before the callback is executed. Once the file has been read, then the callback is executed, outputting the file's contents to the screen using console.log. Are you with me so far? How about another example with output this time? This example application reads a 1,000,000 word file, derives a key based off the file's contents, then returns the string representation of that key. Let me run it, then let's walk through it. This JavaScript module called example3.js just wraps business logic in the file processor module so it can run standalone. The logic is in file processor.js in the process file sync function. Every line of JavaScript code you see here runs synchronously from top to bottom, and this is reflected in the output. Now let's look at its asynchronous counterpart. This JavaScript module called example4.js wraps the logic in file processor.js's process file function, but performs the same business logic as the previous example. The file is read, the contents are used to create a derived key, and the string representation of that key is returned to the caller example4.js. The difference is that process file is doing this asynchronously. Let's run it and then walk through the output. There we see the mainline start message, followed by the message processing file and the file name. Then the process file function is invoked and is passed two things: the name of the file to be read and an anonymous callback function that will be executed when process file is finished. Because the I/O is non-blocking, the I/O request runs in the background, leaving the V8 thread free to continue running, and the very next line of output is the end call we see here. That whole sequence takes about 3 milliseconds, as we can see from the timestamps. If we look inside the process file function again, we see there are two asynchronous requests going on serially, that is, one after the other. First the file is read, and when that is finished, its callback is executed, outputting this message roughly 40 milliseconds later. Then the file's contents are used to compute a derived key, again asynchronously. Once the derived key has been computed, its callback runs roughly 214 milliseconds or so later, and then invokes the callback provided by example4.js when the call was initiated in order to return the results. Hopefully that gives you a better idea of the difference between how synchronous and asynchronous code runs. The code examples you just saw me run are available in GitHub, so be sure to check those out. Check those. See what I did there? One thing you might have noticed in the previous examples, both examples run the same business logic, yet the synchronous code runs faster than its asynchronous counterpart. I'll run those again, this time from the command line so you can see them head to head. First, I'll run the synchronous example, example3.js. Now I'll run the asynchronous example, example4.js. As you can see, the synchronous example ran about 20 milliseconds faster. The key to Node's awesomeness lies not in pure speed, but in its scalability. That is, its ability to handle many simultaneous requests. Let's put that to the test. I've written a wrapper around both process file and process file sync so we can execute those methods in an HTTP server. The process file URL runs the asynchronous version, while the process file sync URL runs the synchronous version. Combined with a load test tool like Apache Bench, which comes with Apache Web Server, or load test from the NPM registry, which you can install through the NPM CLI, we can find out whether or not this asynchronous code scales as advertised. Spoiler alert, it totally does. I'll go to a terminal window and start the HTTP server, which is in example5.js. Then, in a separate terminal window, I'll run the load test command. I'll run the synchronous test first. I'll tell load test to run 100 tests, making sure that there are 10 concurrent requests at all times. The HTTP method is post, and the URL is localhost port 8080 process file sync, which runs the synchronous code. Load test lets me know the progress of the test and prints out a report at the end. And here are the results. To run 100 tests, it took just under 17 seconds with a throughput of 6 requests per second. Now let's run the asynchronous code. Same parameters except the URL, of course. And the results are in. 100 tests run in just over 5 seconds with 19 requests per second throughput. The asynchronous code was 3 times faster. Maybe there's something to this whole Node asynchronous scalability thing after all. By the way, the code examples you just saw me run are available in GitHub, so be sure to clone a copy so you can experiment for yourself. And there you have it, Node's module system, the non-blocking I/O model, and how to run load tests. Make sure and check out the Node.js course available from IBM Code. A link to the course is in the video description. I hope you enjoyed the video. I'm Steve Perry. Thanks for watching, and I'll see you next time. So long.